Good morning and once again welcome to my YouTube channel, Pearson and Excel International Math by Mr. Kamoto. And in this video I want to wind up set 2 and I want to talk about set builder notation, and I am on page 95 of IGCSE book 2. And in this one I want to express how we can show or we can present sets. And we are told that sets can be described using a set builder notation. And a good example is where we have a set A, which can be equals to x, and that x itself is greater than 2. We can talk about x, A being any number x, and that x is greater than 2. So we can talk about A starting with 3, 4, 5, moving forward, because it satisfies exactly being greater than 2. If you talk of something like B, which is another value of x, and x is less than 2, or x is greater than 2, this one we have to look for numbers that are less than 2, and at the same time those numbers are greater than 2. This cannot be the same numbers. There is no number that exists, it is less than 2, and at the same time it is greater than 2. We cannot be having the same number. So we're going to have this one. This one can be written, as x is x less than 2, or, and in this case we have to go for union. We have other values of x where x is greater than 2, and this one talks about union. It can be less than 2 or it can be greater than 2. So this is B for you. Well, this is just an example of built-in notation, but of course let us look at some very popular methods of expressing sets. For example, we have natural numbers. These natural numbers, these are positive natural numbers. The way we do the counting, 1, 2, 1, 2, 3, 4, 5, moving forward, those are the natural numbers. We may have these are integers. These are integers denoted by capital Z. These are integers. And integers, they include negatives. Integers include negatives. So we may have -2, -1. We have 0. So we have 1, 2, moving forward. Those are the integers. They include negative numbers. We have one which is denoted by Q, is a set of rational numbers. These are a set of rational numbers. And what are rational numbers? Rational numbers are the numbers that can be written as a recurring. This can be written as recurring decimals, or terminating decimals, or terminating decimals. These are denoted by Q. Of course, if you look at like irrational numbers like √2 or pi, they do not recur, they do not terminate, so Q does not contain such. But we have irrational numbers. But let's talk about R is a set of real numbers. These are sets of real numbers that make sense. and something which is real. For example, you may have a triangle that is 1 1 and it is 90 degrees. This we have the hypotenuse. So according to the law of Pythagoras, 1 squared is 1 plus 1 squared is 2, and the root of that you have that is root 2. So it is a real number. This is real. It can happen. Root 2 is real. So we have root 2 or even pi is real, because we talk about pi r squared when we want to get the area of the circle. And I want us to go to just directly to example 4 and explain something. Express in set builder notation A the set of natural numbers which are greater than 2, and that is it. This is just x, and x itself is greater than 2. It's simple as that. And of course, at that particular point, you have to know x is a member of natural numbers. X is a member of natural numbers. So a set of natural numbers which are greater than 2. Those numbers have to get the name general x, and x itself has to be greater than 2. X stands for anything, any value, and x has to be greater than 2, and x is a natural number. That's just what it says. And a set of real numbers greater than 2. There's a difference between natural numbers and real numbers. Part B, set of real numbers greater than 2. It's the same thing. We have x, and x itself is greater than 2, but in this case x is a member of real number. X is a member of real number. So real numbers means just real, just like we've explained here. It can be anything depending on mathematical notation there. And of course, if you look at this, the set A is not equals to set B, because in set A we are talking about natural numbers, in set B we are talking about real numbers. Okay, but how does that difference just occur? Natural numbers, we could be having 3, 4, 5, natural numbers 6, 7, 8 moving forward. But when we come to real numbers and they are greater than 2, we could be having that 3 years. We could be having root 5 years, because root 5 is greater than 2 and it is a real number. It is a square root of 5. We could be having that 4 years. We could be having root 6 years, and these are real numbers. Get the difference. And in the same video, I want us to just explain example 5 because it's not just big. Let's talk about example 5 to wind up this topic. And example 5, list these sets. It's talking about list these sets. List these sets. And the first set is a certain number x, and x itself is even, and x is a natural number. When we talk about even and it is natural number, that means we don't have negative the way we count 1, 2, 3, 4. So the first even number is 2, 4, 6, 8, moving forward. That is exactly what we mean. And those are the sets of numbers that we are talking about. Let's talk about part B. Part B, list these numbers x, and x itself is equals to 3y, and y is a natural number. Natural number starts from 1. And when x is 1, 3 times 1 is 3. You know, x is 3y. And the natural numbers start with 1. So y is a natural number, meaning we can even start from 1. When we have 1, 3 times 1 is 3. So you realize that the very first member of this set is 3. 2, when y is 2, 2 times 3 is 6. Then we have 3 times 3, which is 9. We have 12, we have 15, moving forward. And that is just like what we have been able to understand in this particular example. So yes, set notation, building notation, please follow, subscribe, and share widely. That's the end of this topic. I'm very sure we're going to get sets ahead, and this is just a preliminary or rather fundamental information about sets. Okay.